Welcome to your Introduction to Statistics, Unit 5, Lesson 2. Today you're going to learn to use the standard normal table to determine probabilities based on the area under the standard normal curve, and then you're going to learn how to find the same probabilities using your calculator. Alright, remember the standard normal distribution is the z distribution. The mean is 0, the standard deviation is 1. Here we have our nice normal distribution. So since the standard deviation is 1, 68% of the area is between negative 1 and 1, 95% of the area is between negative 2 and 2, and 99.7% of the area is between negative 3 and 3. Remember, any x values can be converted to z-scores, and they're not always going to end up on an integer, so you could end up with a z-score of 0.27. Well, how do we find the area to the left or to the right of that? That's what we're going to talk about today. It's extremely important that you get that any normally distributed x's can be translated to the standard normal curve, to z-scores. So we can go back and forth between any normal curve and the standard normal distribution. The areas underneath the two curves are the same. The total area is 1, and so that's another important fact. Okay. To use the table, you either need to use the appendix in your book, or I will give you a printout. The types of tables that we will use are left tail tables. In other words, when you look up a z-score, you're going to find the cumulative area to the left of the specified z. Well, what if we want the area to the right? We'll talk about that in just a minute. To find the area to the left of a given z-score, you're going to find the row associated with the sign, units, and tenths portion of z in the left column of the table, and then you're going to move across the selected row to the column headed by the hundredths digit of the given z. So let's look at that. Let's find the area to the left of z equals negative 2.84. So you would make sure you are in the negative portion of the table, which we are right here. First thing you do is you find the row associated with negative 2.8. Okay, so you focus on the negative 2.8, you find that row right here, okay, and then once you know which row, you focus then on the hundredths digit and you find the appropriate column that goes with that. So for 4 in the hundredths digit, so 0.04, we're looking at this column right here. So we've got our row, there's our column, and see where the column and the row intersect, the 0.0023, that is the area that we're interested in, the area to the left of negative 2.84. Alright, so to find the area to the left of a given negative z-value or positive z-value, you're just going to use the table entries directly. Okay, you just find the correct z-value, the table entry is going to give you the area to the left. To find the area to the right of a given z-value, you can always do 1 minus the area to the left, okay? Because the area to the left and the area to the right have to add up to be the total area under the curve. You can always do 1 minus the area to the right. Okay, so that's something you can always do. If you have a positive z-value, another way that you could find the area to the right is use the symmetry of the table and just look up the negative z-value, the opposite of it, and use the area to the left. But that might be a little confusing, so you might want to just stick with the 1 minus the table entry for finding areas to the right. Now, to find areas between two z-values, so here we're going from z1 to z2. What you do is you find the area to the left of the larger z-value. Okay, so you get this. But this area has too much because it has the whole tail. We don't want the area to the left of z1. So what you do is you take the area to the left of z2 and you subtract off the area to the left of z1, and that leaves you with just the area between z1 and z2. We're going to treat any area to the left of a z-value smaller than negative 3.49 as 0. And the area to the left of a z-value greater than 3.49 is 1. Alright, so go ahead and grab the copy of the table, either a copy that I gave you or look in the appendix of your book. So Go ahead and find 1.64. Because we want z less than 1.64, that means the area to the left of 1.64. So if you use your table, you'll see that that table entry is 0.9495. That's the area we're interested in. Okay. Now let's try again with negative 2.71. Go ahead and pause me if you need to, but find negative 2.7 row and then go to the 0.01 column. And you're going to use the entry because this is less than, which means we want the area to the left. And so that's 0.0034. All right, for 0 less than z less than 1.24, you're going to take the area to the left of 1.24 and you're going to subtract the area to the left of 0, and that's going to give you 0.3925. So go ahead and stop and find the area to the left of 1.24, which should be 0.8925, and then find the area to the left of 0, which should be 0.5. So 0.8925 minus 0.5 is 0.3925. Okay, try again with 0 and 1.60. You should get 0.4452. Now, for the next one, you're going to do the area to the left of 0, so 0.5, minus the area to the left of negative 2.37, and that's going to give you 0.4911. Between negative 3 and 3, same process. Kind of gets a little overkill here. If you get confident in this, then feel free to move through it kind of quickly. If you're struggling, do the area to the left of the large value minus the area to the left of the small value. You get 0.9974, and for our next one we get 0.9322, and finally 0.0774. One more like that, and we get 0.2254. All right, now let's just do some that are to the right. So remember, when it says greater than, you're going area to the right, so you do 1 minus whatever the table entry is for this particular z-score. So you look at 2.39, do 1 minus that area to the left that it gives you, and you get 0.0084. Z greater than negative 1.43, do 1 minus the area to the left, and you get 0.9236. All right, to work with any normal distributions, you're going to convert your x values to z values using the formula z equals x minus mu over sigma, and then use the table to find the corresponding areas and probabilities. We tend to round z values to the hundredths position before using the table because that's how the table's set up, and then we leave the area results with 4 digits to the right of the decimal point. Okay, so the amount of time it takes for a pizza delivery is approximately normally distributed with a mean of 25 minutes and a standard deviation of 2 minutes. If you order a pizza, find the probability that the delivery time will be between 25 and 27 minutes. So you need to get the z-scores that go with those. So let's see, for 25, you're going to have 25 minus 25 over 2, so 0 over 2. So 0, and 27 minus 25 is 2, divided by 2 is 1. So you want the area between 0 and 1 for your standard normal table, and so that'll give you 0.3413. Less than 30 minutes, let's see, the z-score for that would be 30 minus 25, which is 5, over 2, so 2.5. So you want the area to the left, since it's less than, of 2.5, and that gives you 0.9937. On this next one, we have 22.7 minus 25, so that's going to give you negative 2.3 divided by 2. The area to the left of negative 2.3 divided by 2 would be 0.1251. All right. To use your calculator, it's super duper easy. You're going to go to Menu Statistics, because you're in statistics class, we're interested in a distribution, and we want normal CDF because it's a cumulative area that we're interested in. You're going to enter the lower bound and the upper bound, press OK. So lower bound is going to be your bound on the left, upper bound is going to be your bound on the right. If you're interested in the whole area all the way to the left, you're going to go from negative infinity up to your z-score. If you're interested in the area to the right, it's going to be z-score to positive infinity. So here again is the left tail case. It's going to be negative infinity to the z-score that you're interested in. Boom, it'll give it to you. And if you want the right tail case, it's going to be the z-score up to infinity. And that will give you your value that you're interested, the area underneath. So convert to your z-scores, just like we did last class period, and then use the calculator or use the table to find the areas. Now, here's the thing. You are welcome to use your calculator, but if you're going to use your calculator and that's going to be the method you rely on, you got to bring your calculator to class. Okay, so for those of you who struggle a little bit with remembering your calculator, you really need to learn how to use the table as a backup method, just in case you have to do a quiz or a test without your calculator. Okay, guys, go ahead and try those problems to try on your own. We'll go over them in class. I'll be happy to answer any questions that you have at that time. Thank you for watching the video and taking good notes. I will see you in class. I hope you have a great day.